Today we're going to learn about the determinants of square matrices. So we're going to start with 2 by 2 matrices. So that would be any matrix that has 2 rows and 2 columns. So the determinant is a number associated with this matrix. We'll see what we can do with a determinant later on, but today all we're doing is calculating. So let's give this a name. Let's call this matrix A. The determinant of A we write like that, like an absolute value sign. So the determinant of A is like this, and the way we calculate it is we multiply A times D, so that's AD. We multiply B times C and find the difference. So if matrix A looked like this, 2, -3, 1, 2, the determinant of A would be 2 times 2 minus -3 times 1, which is 4 plus 3, or 7. Now a 3 by 3 matrix is going to work a little differently. So let's say our matrix, let's have 0, 3, 4, 2, -1, 0, and 1, 2, 1. Okay, so the determinant of A, we calculate that by rewriting the matrix. Okay, so we just copied the numbers from the matrix we were given, and then we're going to copy again the first 2 columns, just the first 2. So we'll have 0, 3, 4 again, and 2, -1, 0 again. Now the determinant of A, we calculate as follows. So you start up on the top left, and we're going to multiply down the diagonal. So the first diagonal we have is 0 times -1 times 1. So that product is just 0. The second diagonal, we've got 2 times 2 times 4, which is 16. And the last diagonal, we've got 1 times 3 times 0, which is another 0. Now notice after we find the product with all 3 of these that we've run out. There isn't another diagonal with 3 entries. So we're going to stop there, and we're going to subtract the diagonals from the other direction. So now we're going to start at the top right. So we'll do 2 times 3 times 1, which is 6. Then we're going to do 0 times 2 times 0, which is 0. And then the third, we've got 1 times -1 times 4, which is -4. -4 here. So that's 16 minus 2, which is 14. So the determinant of A is equal to 14. Okay, let's look at another one. Let's do -2, 2, 3, 1, -1, 0, and 0, 1, 4. So let's call this matrix B. So to find the determinant of B, we're going to copy the matrix again, and then we rewrite the first 2 columns. So -2, 1, 0, 2, -1, and 1. We start at the top left and find the product of all the numbers in the 3 diagonals. So starting up here, we've got -2 times -1 times 4 is going to be 8, plus 2 times 0 times 0, that's 0. 3 times 1 is 3. Minus. Now let's go the other direction. 2 times 1 times 4 is 8. Negative 2 times 0 times 1 is 0. And the third is 3 times negative 1 times 0, which is 0. It's nice when there are zeros in there. So then we've got 11 minus 8, which is just 3. So the determinant of B is equal to 3. Okay, let's try another one. C equals and if you want, you can pause the video and try this on your own. But we rewrite the first two. Okay. So the determinant of C, we've got negative 5, 0, and 0. The other direction, we've got 0, 0, and 0. So that leaves us with negative 5 minus 0, which is just negative 5. So I'd like to point out something kind of cool about this matrix. Up here we've got a triangle of zeros. Now when that happens, your determinant is going to be just the product of the diagonal. So if we just found 1 times negative 1 times 5, we would also get the determinant. But again, that only happens when we have a triangle of zeros above or below that diagonal. So in our course, we're really just focusing on matrices or determinants of 2 by 2 and 3 by 3 matrices. But if we have a square matrix that's larger, and you can identify at least one triangle of zeros above or below, you can find the determinant just by finding the product of the diagonal. So this one would be negative 1 times 3 times 2 times 4 times negative 2. And that comes out to be a positive 48. So if we want to find the determinant of a 2 by 2 matrix, we find the product of A and D and then subtract the product of B and C. For a 3 by 3 matrix, we rewrite the matrix and copy the first two columns again. And then you're going to find the products on the diagonals. 3 this way. So you find the products in this direction and you add them together. Then you find the products in the other direction, add those together, and then find the difference between.